This is a really key problem, number 6 over here, and we'll try it out for size. Here's the point that I want to try to make is that I don't need to FOIL this thing out. I could first outer inner last the numerator and first outer inner last the denominator and then have at that. And then only take the leading term. But really, I'm only interested in what factors or what pieces will give me the leading term. And I would say the 2x and the negative 6x. Alright, here, let me prove it to you. What I have is 2x minus 1, 1 minus 6x. And I'm only going to take a look at the numerator here. So if I FOIL this out, I've got 2x, because that would be first times first, minus 12x squared minus 1 plus 6x. Right? Yeah, alright. And if I put that in order from biggest to smallest and combine like terms, I have negative 12x squared plus 8x minus 1. But I don't care about any of this stuff. I only care about the 12x squared because I'm looking at when x goes to infinity. So essentially, I could have just multiplied the 2x and the negative 6x, and I got my 12x squared. So I didn't really even need to FOIL it out when I'm specifically looking at only the x goes to really large numbers. Now for the denominator, I'm going to just use the fact that I have the 2x here and the 2x here, so that would be 4x squared. And I just explained to you why I can do that, so no one's going to complain. Essentially, in the numerator, I just have negative 12x squared, and in the denominator, I have 4x squared. This cancels that. This tells me my horizontal asymptote is negative 12 over 4, also known as negative 3. So I have a horizontal asymptote here, down here at negative 3. Where are my vertical asymptotes? That's a part of later graphing, so I don't need to worry about that just yet. But essentially, I would say that this graph probably looks something like this. You can't really say for sure unless you actually plot these points and all of that kind of stuff. But I'll give you points for anything that you say where it's approaching a horizontal asymptote below 0. I'd be fine with that. Let's see. I think maybe this one would be good. This is pretty simple. I'll just do this one real quick. I shouldn't put an equal sign, because it's not equal to sign, but I'm making an approximation based on if x were really, really, really large, the only important pieces would be the 2x4 and the 3x4. I'm sorry, 4. That kills that, and so my horizontal asymptote is at 2/3, which is about here, something like that. Let's try graphing these, and let's see if I got somewhere anywhere close. What I'm going to say is the vertical asymptotes for this previous problem over here, let's just solve those just to try. That's when 2x plus 5 equals 0 and 2x minus 5 equals 0. Excuse me, sorry. That would be x is equal to negative 5 halves and x is equal to positive 5 halves. So I would say there's two vertical asymptotes at negative 5 halves and positive 5 halves. There's also a horizontal asymptote at negative 3. Let's see. And you know what? I'm going to put in those vertical asymptotes in there. Let's see. That would be x equals 5 over 2. And x equals negative 5 over 2. And I have y equals negative 3. So these lines that I just drew in here should be the asymptotes. Let's actually put in the function and see what they have. What was the function again? It was 2x minus 1, 1 minus 6x. Okay. So 2 parentheses. 2x minus 1, 1 minus 6x. And on the bottom, it was a 2x plus 5, 2x minus 5, right? Yeah. Okay, let's see. 2x plus 5, 2x minus 5. Yeah, perfect. Okay, check this out. There's a vertical asymptote right there. You see it? It's right there. And it doesn't touch these vertical asymptotes. Here's a horizontal asymptote. You know what's interesting is that You know how I said that it would look something like this right here? Where on the left side it comes in from the negative side or below the asymptote and goes towards it. On the right side it comes in from the top and goes down like this. Um, Actually, even though the graph looks like this, I was technically correct. Because if you zoom in over here, you can see that um, this red graph, what it does is it crosses this vertical or horizontal asymptote and goes above it. But then as you go further out, what happens is it doesn't just keep going up. It actually goes back down, but gets closer and closer to the number 2. So you can see that this red graph doesn't diverge. By diverge means I say as it gets further away, it gets further away from the purple line. It actually gets closer to the purple line again. So it is technically coming from above the purple line and coming towards, or yeah, coming in from above the purple line, coming towards the purple line. So my guess as to how this thing looked was actually correct. Even though it doesn't look like that, it actually kind of looks like this. But if you zoom in far enough, you'll see that I was right in the first place. Haha.